Hi, I'm Mike Ferguson from Vanadium Labs. I'm here today with Izzy to show you how to use NUKE, the Nearly Universal Kinematics Engine, an easy-to-use PyPose extension that allow you to put a custom inverse kinematic solution on your Arbotix-powered hexapod or quad. To use NUKE, you'll have to install the latest version of PyPose. Your PC will also need an XP and Explorer. Izzy has an Arbotix robocontroller, an XB radio. The XB radio could also be replaced with an FTDI cable. To get started, we'll load PyPose and create a new project. We enter the name of our robot and the number of servos. We can then open a serial port to communicate with the robot. We'll now switch to the NUKE screen. NUKE currently supports hexapods and quadrupods with 3 degrees of freedom. It currently supports lizard-style legs, and very shortly will support mammal-style legs and 4 degree of freedom lizards. Support for low degree of freedom bipeds is also in progress. After selecting our IK type, we'll select the number of legs, 4 for Izzy. Finally, we'll take some measurements of our robot and input them. Izzy has 3 degree of freedom legs. A coxa servo moves the leg back and forth. A femur and tibia servo move the leg up and down and in and out. We need 3 measurements for each leg. All measurements are in millimeters. The coxa length is measured between the coxa and femur servo in the horizontal plane. The femur length is measured between the femur and the tibia servo. And the tibia length is measured between the tibia servo and ground. Note that on a leg such as Izzy's, we'll measure directly between the tip and the rotation point, not following the actual contour of the leg. We also need 2 dimensions for the body. The first is the distance from the center of the body to the coxa servo in the front and back direction. If we measure between the 2 coxa servos, we'll divide that in half. The second is from side to side between the coxa servos. Again, we'll divide that in half. This is the Y direction, and from front to back is the X direction. Having entered our body dimensions and leg dimensions into NUKE, we can now capture the limits and the neutral position. Limit capture under NUKE is very simple. We'll click Capture Limits, and a dialog will come up asking us to move servo 1 to one extreme. In this case, servo 1 is my right front tibia. It's already pushed up against the edge here as far as it can go. We'll click OK, and we'll move the servo to the other extreme. We then progress to servo number 2. It'll ask us one extreme. We're there. And the other extreme. If you make a mistake, there is an Oops Back Up button. You can also cancel out of this. NUKE will automatically determine which end is the minimum and the maximum. One thing to be very careful about with this is to make sure that if your servos can go very far, that you don't go outside the 300 degrees of rotation. The next thing we'll do is capture the neutral position. When you click on Capture Neutral, a dialog will come up showing you how your robot should be positioned. In the case of a lizard-style robot, such as Izzy, we want to have the femurs horizontal and parallel with each other from above, and the tibia straight up and down. Remember, we're looking at the tibia being the point between the tibia servo and the ground, not necessarily the actual contour of the leg. Once we've put Izzy into that position, we'll click OK, and we capture the pose. Now this is just like any other pose in PyPose, and we can go back and edit it if we need to using the pose editor. Now that we've captured our limits and our neutral position, we need to do a sign test. We'll click Go on Sign Test. and Izzy pops into position, his neutrals actually. We'll click OK. And we want to pay attention to how Izzy moves. The first question is, did my right front leg move forward? And it did, so the sign is correct. We'll click yes. It'll then do our left front leg move forward. And yes, we were correct here. Did my right rear leg move backward? Yes. We click OK. And the same. We then get asked if it moved upward. We're checking the femur servo now. We say yes. And the question then is, did it move inward or outward? If the tibia servo is wrong, it'll kick in or out. And so we'll click no, and it'll fix that. But in this case, our leg is still straight up and down. And we continue through with all of our servos. We're now ready to export our project. We'll click on Export, and we select a folder that we want to store things in. It helps to put it in the folder that you're using to store all of your Arduino sketches. So I'm going to create a folder here for our test robot and say Open, and we export that there. We can now load the Arduino environment, do Sketchbook, Test. And what we have here is an entire sketch. This sketch runs through and has the robot stand up and then waits for commands. So I'm going to connect up my programmer to Izzy, and we'll load our sketch. Once the sketch is loaded, we can use the test drive tool within NUKE to control the robot. Test drive uses the same protocol as the robotics commander. When I start Izzy up this time, he's going to slowly stand up. And this is all being controlled by IK now. I've now loaded the robotics commander test drive tool, and further gate optimization can be done by hand, but Izzy is already pretty functional.